Hello everyone, this is another video from Easy Electric series, and today we want to see how we could use the analog input, more voltage input, to able to control the speed of the motor or the frequency of the VFD. So this is very similar to what we did with the variable resistor, but here instead of having these variable resistor and somehow change these voltage on terminal 13, we directly connect terminal 13 to the power supply that we could adjust the DC voltage, and the negative of the power supply goes to the terminal 14. So as you see here, I connect the positive of the DC source port terminal 13 on the VFD, and the negative connect to 14, which is technically do the same thing. We are actually adjusting to the DC voltage 0 to 10 should be able to adjust the speed or frequency of the VFD between 0 to maximum frequency that we have. So first we do this wiring, and let's take a look to the VFD programming and what we should do. So before we go there, make sure you add this jumper wire between 11 to 1 if already you actually open it. So that's the first thing you need to check. And for a programming side, let's see what we need to check. So P36, we should be check, turn that to the 0, so which is we are going to control from the keypad. P37 stop mode should be ramp. So P38 should be similar to whenever we use remote variable resistor, should be still 2, which is 0 to 10 input, but this time we give that through the DC power supply rather than the variable resistor. So that's actually is all. So just before going and see that on action, so just be careful whenever you actually change the DC voltage, these power supply between 0 to 10. Technically, what should be happen on the 0, it should be around the 0 frequency, motor should be stopped, and whenever you give increase to the 10, the speed should be go up. At the 10, you should have the max frequency that you already adjusted. For my case is 60 hertz. So that means changing with the Z, moving from 0 to 10, it should be increase the speed. And whenever you are on the 0, technically it should be 0. For some power supplies or in some environment, which that's very noisy, even whenever you put on the 0, so still you actually get some very small voltage there. So that could be because of the noise or because of your power source that couldn't be give absolute 0. So that means you actually see still motor is very tiny is moving. So for fixing that, somehow we have two parameters. You actually could increase this level or 0 level, and also these 10 that you have. Let's see which command those are. So for doing that, we actually have one parameter which is A110. This is for analog in 0 to 10 low. So technically what these parameters do, it somehow move low voltage a little higher. So that means it's moved from the 0 to a little high, that whenever you turn the old knob of the variable source to the 0, whenever it's not 0, it still is actually turn that off. So if that's your case, you could actually start with 0.1. If it's not still moving at 0 voltage, you could increase that to 0.3, should be fine. Yeah, in the same way, you could actually use A111, which somehow change the high point of the voltage, and you could actually change that a little bit. So let's go to the wiring for training set and see how we could run that based on what we explain on the data sheet. Okay, let's take a look to the setting that we have here. So I actually add the external DC source, which is here I could change the DC value that is connected to the port 13 and 14. So as you see, my ground, which is connected to the terminal 14, and the positive of the external source connected to the port 13. So because I use the keypad, still I have a jumper wire 1 to 11, and that's it. That's all wiring that you need. So let's start the motor and see if we could adjust the speed of the motor with external DC source that we have. But before to do that, let's check few parameters here. So number one is P36. So let's check P36 and make sure we are telling 0, which is the control with the keypad. We check P37. Make sure we have on the ramp. So P37 is actually 0 is ramp. P38, which is going to the speed reference, we should put on the 2, which is 0 to 10 volt input. Similar with the variable resistor, right? Instead of the variable resistor, here the variable source give the same thing, 0 to 10 volt. So let's do check P38, and P38 should be on 2, which is correct. So I think we are all set. Let's just put on the frequency and let's start our motor. So right now, let's actually start the motor. So I started the motor. So it is 0, there is no speed on that. So slowly I'm going to increase the frequency. As you see, motor start to spinning and the frequency goes slowly up. So I'm increasing the DC source and you see how it goes actually up to the 10 volt, which is here is 10. I stop on the 10. Sorry, the 60 is my max. So as you see at the 10 volt, it's actually split with 60 hertz. And if I go down, it should be actually go all the way down. So now the question is, at 10, I get the max frequency, which is 60 for my case. So the question is, could I really stop the motor whenever I go all the way to 0? Let's see that. So it goes to the 0 frequency, and as you see, my motor stopped. So in some cases, that depend on your external DC sources. When some DC sources, even whenever you have 0, you have some noise, or the DC source completely couldn't make you a 0 volt, still you have a tiny voltage there. That means even whenever this shows 0, your motor actually turns. It's not my case, but in some cases that's happened. So in that case, you should actually use the parameter A110, which is with parameter A110 and 111, A111, you could actually change the high level and also the bottom layer of your voltage. So that means, in another word, you could actually, with A110, you could move actually the low voltage a little higher. And that I just show that. It's not my case. As you see here, it's actually 0. My motor is stopped. If not, you just come here, goes to the A110. So my default should be 0. You just give that you start with 0, maybe 0.3. So our 0.1. So technically what it's doing, what these A110 do, it's actually move the low voltage a little higher. Instead of the 0, you move a little higher. So same for A111. If you want to change the high point of the voltage from 10 for a little higher, so you could actually use A111. So I hope you like this video. Thank you for watching.